Section 8.5, number 13. We're first going to graph this curve using the parametric equations that we have below. We'll use a 3-column table with a t, an x, and a y. And then for part B, we'll eliminate the parameter of t and plot it using the rectangular forms. Alright, so we should get the same graph. So let's do part A first. So it says graph the curve defined by the parametric equation using the specific interval and identify the graph if possible. So x and y we don't know that exact relationship at the moment. So we will find out that relationship through t. So we're going to plot some points between 0 and 2 pi for t, and I can see that t is an angle. So I'm going to use some special points on the unit circle. Let's do 0, pi over 2, pi, 3/2 pi, 2 pi and 0 will be the same. I may do just one more between some of these special angles to make sure it looks like what I think it should look like. So when I plug in 0 for x, or 0 for t, sorry, for x I get cosine of t is 1, so 4 times 1 is 4, and then sine of t, sine of 0 is 0, so that would be 0. Pi of 4, cosine, oh, these are both going to be pi over 2, so just going to give myself a little extra space in here. So radical 2 over 2 times 4 gives me 2 radical 2, and times 3 gives me 3 radical 2 over 2. And then pi over 2, cosine of pi over 2 is 0, times 4 is 0. And then for y, sine of pi over 2 is 1 times 3. And then pi, sine of pi is 0. Wait, that's not right. Sorry, wrong equation. For x, we want cosine of pi, which is -1 times 4 gives me a negative, so I can see a pattern already developing here. And sine will be 0. And then 3 pi over 2. Cosine is 0. So that'll be 0. And sine of 3 pi over 2 is -1 times 3 gives me a -3. So I can see a nice pattern developing there. Okay, so I made myself a grid. I can see my x's are going to range from -4 to 4, and my y's are going to range from -3 to 3. So let's see here. We have a point at this point here. Let's do x is 4, y is 0. And let's jump over here to 0, 3. And then here we have -4, 0. And here I have 0, -3. So it looks like it's going to be an ellipse. I did this extra point just to try to kind of check that theory. So let's see, 2 times radical 2. That's 2 point something. And then 1.5 times radical 2 is, might not have been the best point because then I still have those radical 2's to deal with. So let me get a calculator. Okay, so for 2 times radical 2, I get 2.8-ish. It's approximate. And then the other one I get 3 times radical 2 divided by 2 gives me 2.1-ish. So that is about 2.8 to 2.1, about here. And that seems consistent with my theory that this is an ellipse. So I have an ellipse. So if I'm kind of guessing the equation here, it looks like I have a horizontal radius and a vertical radius of 3 and that. Alright, so that's an equation of this ellipse. Okay, moving on to part B. Eliminate the parameter and write the corresponding rectangular form. So with the trig functions, I don't really want to get an angle by itself because then I have cosine inverses in there, and that would not give me my rectangular form. So I'm going to keep the cosine, I'm going to solve for cosine t and sine t, solve for that trig function. So I'll solve for cosine t in this equation, and I get cosine t equals x divided by 4, dividing both sides by 4. And then I plug it into there. Nope, there is no cosine t there. Sorry, so I'm also going to solve for t in this equation. Solve for cosine of t, sorry. So again, solving for the trig functions, sorry, would give me y over 3. Now I have the trig functions cosine and sine, so I got to look for an identity that relates those two. And that gives us the Pythagorean identity, sine squared x squared equal sine squared t equals 1. So if I plug in this for cosine and this for sine, I'll have a true equation that relates the x and the y. So I have cosine squared plus sine squared equals 1. Actually, before I did this, let me write a preliminary step. So this is just a shorthand for cosine of t squared. And this is shorthand for sine of t squared. So now I'm plugging in cosine. I have x over 4. And sine, I have y over 3. And just plug that into this identity about that relates cosine and sine. And I get that. And then when I square it, I get x squared over 16 and y squared over 9 equals 1, which is an equation of the ellipse that we just graphed. So that is our rectangular form of the equation. So this question had 2 parts. First, we had to graph that circle, the ellipse. So the first part, A, was the graph, and B was to find that rectangular equation. And I do think we were asked to name this graph too. Hang on a second. Identify the graph if possible. So this is an ellipse centered at 0 and has a horizontal axis equal to 8 and vertical axis equal to 6.